As promised, welcome to Tangent. Now, we're not going to do a whole heck of a lot with tangent because most of this course centers around sine and cosine, but tangent sneaks its way in there. So I'm going to do a little bit and just show you how this tangent function works. It's actually quite unique. Okay? Now, what does tangent mean? Mathematically, tangent means this. This means it's a line that only touches the curve in one and only one spot. What do I mean by that? Well, okay, let's deal with our beautiful unit circle. If we dealt with our unit circle, take a look at this. There's our beautiful unit circle right here, which we know has, has a length there of 1. If I chose a point on this unit circle, which is right here, think about this. How do we get to that point? We go x and then up y. Right? So we know that that coordinate is x comma y for that one right there, okay? Now, how does this relate to the tangent? I'll tell you in a second. Now, if we were to do the tangent of this theta, okay? Think about it. The tan of theta is based on TOA. Remember from SOHCAHTOA? Right. Opposite over adjacent. Now, the opposite, of course, being the y. The adjacent, of course, being the x. So that's where the idea of tan theta is y over x. But you know and I know that tan theta on a unit circle, the x is actually the cosine of theta, and the y is the sine of theta, which recall then, if this is y, the tan, I'll use the theta that's here. I guess I can't. The tan of theta then becomes sine theta over cos theta. Oh my goodness. So when you go back to your unit circles, all you have to do is put the y value over the x value, simplify, and you got the tangent for every point on the unit circle. Wild, hey? We'll get into that a little later on. Okay, so let's talk about this then. Let's talk about this a little bit more. What if I'm talking about here? What if I want to look at this entire circle and this wonderful line that touches in one spot? Well, that line touching in one spot is in fact our tangent line. Now, how do we go about finding out something like this point Q? Well, let me show you how it works. Think about this. Tangent is still opposite, which is this length, over adjacent, that's this angle. So tan theta is still opposite, which is here, right, over adjacent. It still works out to be that, right? ADJ, there it is, okay? But think about it. Your adjacent is actually 1 because this is a unit circle. So your opposite here over 1. So tan theta then, oh my goodness, tan theta is opposite divided by 1 is what? It's just the opposite. So this length here, which would normally be the opposite side, I just proved it to be equal to tan theta. That's why the coordinates of this wonderful point here are 1, there's the 1, and the height being tan theta. There's the coordinates. Isn't that wild? Interesting, interesting. Now, here's a couple other things that are wild. Notice that this is a line. So if it is a line, it has a slope. The slope, rise over run. What? The rise of tan theta is right here. The run is 1. So tangent, in fact, is the slope. So that's just amazing. Okay, the value of the tangent is the slope of the line. Oh my goodness. Of course, rise over run. There, yeah, no kidding. Now, also, the tangent ratio is the length of the line segment. It's the length of the line segment now because it is over 1. Look how everything becomes super simple because we're dealing with the unit circle. So this length of this line here is in fact our y coordinate, which is tan theta. Oh my goodness, that was too much, wasn't it? Well, once I show you these examples here, you'll understand everything. You'll understand all of this stuff. You're just going to laugh at how simple it is. The reason why is you have to remember that that has to be a 1, then that in fact is your tan theta. Now, being that you know that that's tan theta, watch how easy this becomes. This becomes so darn easy, it's just going to make you just cry laughing. So we're going to calculate this measure in degrees, and we're going to calculate it in radians, okay? Degrees to the nearest whole degree, radians to the hundredth, okay? Simple, easy peasy. Now, how do you do that? Real simple. Look, remember that this is 1, this is tan theta. As long as that's 1, right? As long as you know that that's 1, you're dealing with the unit circle, right? Then that guy is just plain old tan theta. That's easy to do. So all you have to do is say, okay, well then tan theta then equals to 2. And all you have to do then at that point is go inverse tan like you did in grade 10, and you find out theta. Well, let's do that. Inverse tan of, what was that? 2, wasn't it? Perfect. I get 1.107. Well, what the heck is that? Well, wait a second. 1.107 is in radians. So I got 1.10. It's to the hundredth. So it's 1.11. So in radians, 1.11 radians. Now, what is that in degrees? Now, you can do the exact same thing. You can go out and you can pull out the conversion and go, okay, radians on the bottom, degrees on the top, 180 over pi, or save yourself some grief and just go back to the calculator here, change this guy, go mode, change this guy now into degrees, right? Enter, okay, second quit. Now you see up here, it actually says degrees now. Mouse up, grab this guy here, right? Punch it down here, hit enter, and you see that it's 63 degrees. Okay, 63 degrees it is. Now I can prove that it's 63 degrees by using this formula here, but I just saved you a little bit of multiplication grief, didn't I? Let me prove it. It's 180 divided by pi. Let's go back up here. I'm going to take this answer right here, 180 times 180, right? Boom. And I'm going to divide that by pi, divided by second pi. Boom. There you go. Exactly the same number. 63.4, plain old 63 degrees. So either way you want to do it. If you want to go out and you want to do the conversion, you can. If you want to just go out and redo the calculation, changing your calculator into radians or degrees, away you go. Who cares? Okay, so let's do the next one. Here we go. Look at B. Same kind of idea. Okay, this is 1. That's got to be 10. Now, the only problem with this here, sports fans, is you're figuring out this value here. It wants you to figure out this. Okay, watch out, because that's where you're going to have to start doing that beautiful thing that we love to talk about, and that beautiful thing, of course, is theta r, reference angle. If you know what the reference angle, this theta r is equal to this theta r, then you can find the theta in standard position, which is what we're trying to find right there. Okay, so with that in mind, there's the 1. You know that this is 10, but don't use the negative. Once you determined it's down here, you don't need the negative. You need the absolute value of this. So, okay, here we go. We go inverse tan of 0.6. Inverse tan is 0.6. Why? Because you know that tan theta equals to 0.6. Inverse tan to both sides. If you remember grade 10, okay, gives you theta equals inverse tan of 0.6. So let's go to our calculator. Clear this stuff out of here. Inverse tan, second tan of 0.6. Now, what are we in? Oh, we're in degrees. It says right here, we're in degrees. Okay, so we're going to get a degree value. Boom. That works out to be 30.96, 31 degrees. Okay, so my question then is, if this is 31 degrees, that makes this 31 degrees. And so what is that? Well, that would be 180 minus 31 degrees, right? Because we want to figure out what this position is in standard form. So, okay, boom, that's 9. 3 from 7, of course, is 4. That's 149 degrees. Okay? Standard position, 149 degrees. Now, from there, you can figure out the radians. Easy. Let's do the conversion this time. Degrees on the bottom, radians on the top. Of course, that's pi rad over 180 degrees. So 149 divided by 180 times pi. Okay, 149 divided by 180 works out to be that times second pi works out to be 2.60 is your radians. 2.60. Okay? 2.60 rad. Beautiful. Let's keep on going. Almost done. 2 more questions and we're done. Look how easy. Same kind of idea. But now, look what they're asking you to find. They're asking you to find all the way around. Well, didn't we do this one already? Didn't we do 0.6? Yeah, we did 0.6 right up here. So we found out that that reference angle was in fact 31 degrees. Okay, so let's keep going with that. That means that this reference angle is 31 degrees. So now we can find this entire angle. That's walk in the park, ain't it? Sure, of course it is. That's 360 degrees minus 31 degrees. Okay, of course, that's going to give you 9. 3 from 5 is going to give you 2. This is 329 degrees. Oh, that's just too easy. So our wonderful angle in standard position is 329 degrees. But again, what is it in radians? Okay, convert it to radians. Degrees goes on the bottom. Rads goes on the top. We got pi is 180. All right, so 329 divided by 180 times our pi. Okay, clear. 329 divided by 180, boom, times our second pi, and we got 5.74 rads. 5.74. So 5.74 rads. Now, you're probably saying, well, wait a second. Don't we have to switch the mode of the calculator from degrees into radians since we're trying to find radians? No, we're just multiplying. We're not going inverse tan or inverse cosine or anything like that. Once we do an inverse sine or cosine, we've got to make sure if we're degrees or radians based on the type of question that's being asked. Okay? Let's look at the last one. I promise, this is the last one, and we're going to go on. Beautiful, look at that. Now you're trying to find, oh my goodness, you're trying to find this whole thing all the way around. Well, find me the reference angle. That's easy enough to do because that again is 1. This, of course, is tan. All right, so tan of theta equals to 0.7. Now, I'm going to go inverse tan, but I'm going to do this in degrees first, okay, to give me my theta equals to inverse tan of 0.7. Here we go. Well, let's clear this stuff out of here. Inverse tan of 0.7. I am in degrees, which is indicated right here in your calculator. Okay, so inverse tan of 0.7. Second tan, 0.7. Oh my goodness, I get 34.99, so 35 degrees. All right, here we go. We know that this is 35 degrees, which means that this is 35 degrees. Now, I'm going past 180, so I got to add an extra 35 degrees here. Oh, beautiful. Okay, so that's going to give me 5 and 8. That's going to give me 215 degrees. That's how it works, right? Okay, so that works kind of cool. So all we got to do now is just convert this into, yep, you guessed it, into radians, and we're good to go. So, okay, now in this case, degrees will go on the bottom, rads goes on the top. You got pi here over 180. So 215 divided by 180, 215 divided by 180 times pi. 215 divided by 180 works out to be that, times that by our pi. And look what we got, 3.75. Oh, how cute. Look at that. This works out to be 3.75 radians. And that's how you do tangents of a circle.